Sweet. Day two of I'm gonna call it Project Solomon instead of the Solomon Project. I just think it sounds a little cooler. So yeah, and it's shorter. So day two of Project Solomon. Yesterday we left off on to start working on the first phase, which is gonna be getting something up onto the page. Um, kind of nothing crazy in terms of the material UI components I'll use, just something that will work. And my life is saying that I've only been live for 14 seconds, but I've been live for a lot longer than that. Hopefully, um, that didn't just jump in all of a sudden. Anyway, I'll restart just in case it didn't actually start when I thought it started. This is day two of Project Solomon, or as it was called, the Solomon Project, but I'm just going to shorten it to Project Solomon. Where we left off yesterday is I had just created the Solomon project, and I'll update this actually. Um, well, I don't know. Maybe because the Solomon project just sounds good as well, as opposed to Project Solomon. I don't know what I'll call it. Whatever. Maybe I'll update this. Ignore me. Doesn't matter what it's called. Yeah. So I just created that repo. Excuse me. Yeah. And I had some issues um, with pushing this commit up. So anyway, today we're gonna figure out what's going on with that, and then um, and then we're uh, gonna start working on getting something on the page on the web page, which will probably just be some super basic components. Like it won't at all look like a text exchange between two people. It'll just be like two different sides of the screen, sort of a thing. Um, and yeah, that's and that'll be going off of local storage. So no authentication, no database, like nothing. It'll just be stored in the database and no multiple users, just for me. All right. Um, I'm gonna go ahead and yeah, I don't know why I'm yawning so much. I'm a little tired. It's early, but it's not that bad. Let's hit commit again. See what's going on. No SSH private key found for specified public key. Um, I bet you it's because I've got that old public key. If you remember when I opened up my 1Password, which is my SSH agent, which is supposed to be like managing all the keys, from what I understand. Maybe we'll do like watch a YouTube video on SSH. How does SSH work? SSH agent, something like that. Just to get some more context on it. But from what I understand, you've got SSH private and public keys that come in a key pair, and then you can use an SSH agent to those generate those keys. So I forgot. I'm going to go ahead and override. This will allow me to be on YouTube. I don't know if you can see this little counter up there. Normally, I only am allowed to be on YouTube for, what was it, 15 minutes at a time. So in case I want to, my stream is going to last longer than 15 minutes. So that's me overriding. And the reason why I have it set up that way is because I only have one override a day, and that's for an hour, so long enough for my coding. And And then after that, it's blocked until like 11 a.m., I believe, or maybe 12, basically for my lunch break. So kind of keep my whole morning clean. Um, okay, back to project itself. Um, and let's go through. Is that about SSH? Check for existing key. Let's see here. Not really sure what I'm looking for, to be honest. See, like, where is git config? I think this is where it's having it. My git config. I guess on my in my root. I'm not sure where it's stored. Um, Geez, that's bright. Oh, look at that. I don't even have Darkreader. Let's install Darkreader. This is my go-to make everything dark mode. Um, Excuse me. There we go. Yeah, so that's a lot better. Git config less show origin. That seems about right. Yeah, user signing key. I bet this is it. This is that signing key. I don't know how that works. Like, can I have multiple signing keys? I don't know. All right, let me just edit this one signing key that it's talking about. Because that's the old one. And then once I do that and I update it with the new one, then I'll try again. And if it works, then great. If not, then we'll do some more research on how SSH keys work, generation, watch the YouTube videos, all that stuff. There we go. Basically, these are all hidden folders and files, and on Mac, if you just do Command Shift period, it'll hide and show. So I'm not sure why they got turned off. I almost always have everything showing, whether they're hidden or not. But yeah, I should have my git config here. Um, uh, I know there's also like in the settings or something you can change it. General maybe. Yeah, I don't know. There's a setting that you can come in here and allow to show hidden folders. But I usually just do the key binding, or just Google it. Google is your friend. Okay, just replace that. Let's try and commit one more time. Allow for all applications. We're just going to allow for one. Hey, look at that, it worked. Okay, I am interested though to see um, how this SSH key and all of that works. Why I needed to add it as like a signing key um, to my user object. Yeah, so we're gonna do. Let's see here. I think we're just going to read through all of these and then we'll watch some YouTube videos. So, about SSH. Using the SSH protocol, you can connect and authenticate with remote servers and services. With SSH keys, you can connect to GitHub without supplying your username and personal access token each time you visit. You can also use SSH key to sign commits. Oh, okay. So I can log into GitHub and then I can also use it to sign commits. You can access and write data in repositories on GitHub using SSH, which stands for Secure Shell Protocol. When you connect via SSH, you authenticate using a private key file on your machine. For more information, see Secure Shell on Wikipedia. Excuse me. I'll open it up and read it in just a second. When you set up SSH, you will need to generate a new private SSH key and add it to the SSH agent. Okay, yeah, that makes sense. You must also add the public key, SSH key, to your account before you use the key to authenticate or sign commits. That makes sense. So you're going to have your public and private key, and it's added to your SSH agent to manage everything. And then whatever you're trying to connect to also has the public. And then I'm going to guess there's some sort of reckoning with that to make sure that what you can generate off of the private key matches the public key or something like that. Okay, you must also add it to GitHub for more information, yada, yada, yada. That seems important. Okay. I think we'll want to read this connecting troubleshooting. Maybe not the troubleshooting. But the connecting and the verify commit signatures, all of those make sense. Like signing commit, signing tags, tell Git about your signing key. Anyway. You can further secure your SSH key by using hardware security key, like a YubiKey, which looks like UB. I don't know how to pronounce Oh, there it is. Looks like this. Which requires a physical hardware security key to be attached to your computer when the key pair is being used to authenticate with SSH. You can also secure your SSH key by adding your key to the SSH agent and using a passphrase. Otherwise, you would just be managing SSH keys on your own, I guess. Like the files will just be around. I don't know how that works. Using your SSH key with a repository owned by an organization that uses single sign-on, you must authorize the key. Okay. To maintain account security, you regularly review your SSH keys and revoke any keys that are invalid or may have been compromised. If you haven't used your SSH key for a year, GitHub will automatically delete your inactive SSH key as a security precaution. Organizations that use GitHub Enterprise Cloud can provide SSH certificates, which members can use to access the organization's repositories without adding the certificate to their account on GitHub. If you're using a SSH certificate, you cannot use a certificate to access forks of the organization's repository. Okay, I don't know if I really need to read all of that. Whatever. I'll move on to the agent forwarding, or to the next page after we look at Secure Shell on Wikipedia. Just trying to see how long this is, how much we should really be reading. Okay. Wow, I can have it talk it out. It's pretty cool. Okay. The Secure Shell Protocol, SSH, is a cryptic network protocol for operating network services securely over an unsecure network. The most notable applications are remote login and command line execution. SSH Shell was designed for Unix-like operating systems, so not Windows, and not Linux, I guess. Or is Linux built on top of Unix? I don't know, to be honest. That's probably a very naive question to ask. As a replacement for Telnet and the unsecured remote Unix shell protocols, such as the Berkeley Remote Shell, RSH, and the related RLogin and RExec protocols, which are all use insecure plain text methods of authentication, like passwords. Oh, that makes sense because someone could intercept a password. Sense mechanisms like Telnet and Remote Shell are designed to access and operate remote computers, sending the authentication tokens, i.e., the username and password, for this to access to these computers across a public network in an unsecured way poses a great risk of third parties obtaining the password and achieving the same levels of access to a remote system as that Telnet user. Secure Shell mitigates this risk through the use of encryption mechanisms that are intended to hide the contents of the transmission from the observer, even if the observer has access to the entire data stream. So basically, everything's encrypted to the user, or if I'm connecting from over here to this computer, as I'm going between, if someone intercepts and is looking at exactly what I'm sending over, it doesn't matter, it's encrypted. They can't see it. Finnish computer scientist, I would even not even going to try to pronounce his name. Designed SSH in 1995. Well, that's somewhat recent. And provided an implementation of the two forms of commands, SSH and slogin, as a secure replacements for RSH and RLogin, respectively. Subsequent development of this protocol suite proceeded in several developer groups, including several variants of implementation. The protocol specification distinguishes two major versions referred to as SSH1 and SSH2. That makes sense. I've only ever seen SSH2. I haven't seen one. The most commonly implemented software stack is OpenSSH. Released in 1999 as open source software by OpenBSD developers. Implementations are distributed for all types of operating systems commonly used, including embedded systems. SSH applications are based on client-server architecture, connecting the SSH client to an instance with SSH server. It's that client server. SSH operates as a layered protocol suite comprising of three hierarchical components. The transport layer provides server authentication, confidentiality, and integrity. The user authentication protocol validates the user to the server. The connection protocol multiplexes the encrypted tunnel into multiple logical communication channels. Yeah, I have no idea what that means, but I think we'll just read on a little bit here. SSH uses public key cryptography to authenticate the remote computer and allow the authentication user if necessary. SSH uses several methodologies. In the simplest manner, both ends of a communication channel use automatically generated public-private key pairs to encrypt. To encrypt a network connection, and then use a password to authenticate the user. Okay, so a user has a password, and then they can generate and use the public key pairs. When a public-private key pair is generated by the user manually, the authentication is essentially performed when the key pair is created, and the session may be opened automatically without a password prompt. In this scenario, the public key is placed on all the computers that must allow access to the owner of the matching private key. Okay, so somehow, which the owner keeps private. So I wish I knew more about how this works, but basically I give everyone a public key. Excuse me. I do the magic of computer science and math and all that good stuff. I have the private key that I hold. The public key hops onto all of or I push it to or give it to all the devices or endpoint servers that I want to get access to. And then that way I can go up to them and say, hey, I want access, and somehow use my private key to authenticate myself. I don't think I give my private key over to them ever. I think that always stays on my device. But there's something that I generate using my private key that then they can compare to the public key that I gave them and know that I'm the same person who put that public key on there to begin with. And then that way someone can't. So that's authentication. Someone is who they say they are. That way I'm not some man in the middle attack where, the two servers, we've got me and then the server, and someone can't jump into the middle, see what my username and password, and then use that for a different session. So yeah, anyway, we'll go back to this. While authentication is based on the private key, the key is never transferred through the network during authentication. Oh yeah. SSH only verifies that the same person offering the public key also owns the matching private key. And so there must be it must be so complicated to create a public key that there's no way to reverse engineer that. And so as long as SSH could verify that I have the matching key to the list. A server is going to have a list of public keys, which would be a list of all the users that want to have access to it. Um, so as long as I can prove that I have a matching public key to the or private key to a list of the public keys on a server, then the server can let me in. In all versions of SSH, it is important to verify unknown public keys, i.e., associate the public keys with identities, before accepting them as valid. Accepting an attacker's public key without validation will authorize an unauthorized attacker as a valid user. Um, okay, so yeah, it's important to verify unknown public keys. Oh, I see what you're saying. You got to associate a public key with some sort of identity. Otherwise, people could just start uploading random public keys, and then it'd be the same as someone not having a password. On Unix-like systems, excuse me, the list of authorized public keys is typically stored in the home directory. Oh yeah, there we go. The list of authorized public keys. The home directory of the user that is allowed to log in remotely in a file called home directory. That's the tilde means home. Authorized keys. This file is respected by SSH only if it's not writable by anything apart from the owner and the root. When the public key is presented on the remote end and the matching private key is present on the local end, typing in a password is no longer required. However, for additional security, the private key itself can be locked with the passphrase, which is exactly what was talking about here with SSH key passphrases. The private key can also be locked for in standard places, and its full path can be specified in the command line setting. The SSH keygen utility provides public and private keys, always in pairs. I'm going to guess that the keygen has something to do with the agent as well. Cool. I'm just going to scan through this super quickly. This section possibly contains original research. Most information. Okay. I'm just going to grace this super quick. If anyone wants to read it with me, they can. But for now, I'm not going to read it out loud just because I want to quickly glaze over it and then get back to GitHub. Okay. We won't read through all of the history or the uses. I think we've gotten a pretty good idea of all of that. The architecture would be kind of interesting. But this is getting pretty nerdy, and I don't think we need to know all of this just to be able to use it. Using SSH forwarding to simplify deploying to a server, you can use SSH agent forwarding to securely use local SSH keys. SSH agent forwarding can be used to make deploying to a server simple. It allows you to use your local keys instead of leaving keys without a passphrase sitting on your server. If you've already set up an SSH key to interact with GitHub, you're probably familiar with SSH Agent. It's a program that runs in the background and keeps your key loaded into memory so that you don't need to enter your passphrase every time you need to use the key. The nifty thing is you can choose to let servers access your local as if they're running on the server. This is sort of like asking a friend to enter their password so you can use their computer. I think we might want to set this up so that I bet you right now, every time I make a change, another test, I'm going to have to authenticate. Why is it making me? Okay, it looks like it doesn't. Can I sync those changes without? Okay, never mind. I think 1Password is just completely acting as my SSH agent. But it sounds like normally I'd have to do this manually. It's crazy how complicated and yet simple all these protocols are. Looks like Apple's keychain also on Mac also can act as a SSH key agent. Managing deploy keys. Let's check this about commit signature verification. Using GPG, I don't know what that stands for, SSH or S/MIME, you can sign tags and commits locally. These tags are marked as verified on GitHub so other people can be confident about this change is coming from a trusted source. Interesting. Literally said the same thing. For most individuals, GPG or SSH will be the best choice for signing commits. S/MIME signatures are usually required in the context of a larger organization. SSH signatures are the simplest to generate. You can even upload your existing authentication key to GitHub to also use as a signing key. I wonder what that means. Generating a GPG key is more involved than setting up a SSH key, but GPG has features that SSH does not. A GPG key can expire or be revoked when no longer being used. GitHub shows commits that were signed with such keys as verified, unless the key was marked as compromised. SSH doesn't have that capability. Interesting. Okay, I think there's different things. Signing a commit, and then also just authenticating to GitHub. Sorry. I'm not sure. If I reload, I should have a few commits. Yeah, 3 commits. Look at that. All right. I think we go ahead and start. Well, I'm kind of interested in this, to be completely honest. Computer files are really good. I've watched them before. That'd probably be very helpful as well. Okay, we're going to watch a couple of these. We're going to watch this one, this one. I think this one would be useful as well, and then we'll do the GitHub one specifically. And then I'm going to stop sharing the screen and share just the tabs so you guys get audio. Sweet.
Let's talk about the SSH protocol. So this was first developed in 1995 by Tatu Ullinen, and I know I'm probably pronouncing that wrong, but he was first inspired to develop this protocol after he discovered that there was a password sniffer being used on his Finnish university's network. So you see SSH, it stands for Secure Shell. Before its invention, people would have typically been using connections like Telnet or RLogin to administer remote machines.
We learned or read about all this in that Wikipedia.
But the problem with Telnet and RLogin is that they are not secure at all. The packets that are sent with these network protocols are all sent in the clear. Now, back in the early 90s, before SSH was invented, because with Telnet, I think that that was invented in the early 70s. These kinds of connections that were being made at the time, being unencrypted, wasn't really that big of a concern because the internet wasn't really fleshed out that much. So, most of the time, if you were connecting to a so-called remote machine, it still would have typically been on the same network. Maybe it's a server that's located somewhere else in the building of a campus. But as things progressed and people started sending more and more connections over the internet, over a much larger network where anybody could be listening in between, well, you can probably see how plain text connections would be a problem in this day and age, since these connections are oftentimes used to administer really important machines like servers that might have a website running on them. And you have the administrators who have to enter some kind of a username or password to do work on those machines. So if somebody gets those credentials, then it can really wreak some havoc. So it's very important to use a secure connection whenever you're on an insecure network. And even when you're dealing with local networks, really, because it can be pretty hard to know for sure if your local network is secure when you have a whole lot of people using it and a whole lot of devices run on it. I mean, in this example, the password sniffer was being used on the university's network, right? So with SSH, we are encrypting the data that is being sent over a network. So if somebody is going to be sniffing this traffic, because there's really nothing that we can do to prevent someone from sniffing it, they're copying our packets and trying to inspect them. They're not going to be able to see things like usernames and passwords to log into the remote machines. Now, of course, an adversary, they can still see that there is data being transmitted. So they could tell, okay, this person is making an SSH connection. They can see those packets that are being sent and they can see how many of them are being sent. So there are some inferences that an adversary could make if they're listening in on this connection, but not a whole lot more. It's kind of like if you were to look outside and notice that your neighbor is getting a whole bunch of packages delivered to their house. You could speculate about what they are or what they might be doing. Maybe they're building a new PC or something, but you can't see inside the boxes, so you can't know for sure. Now let's get a bit more technical because SSH, it does more than just encrypt your data. Let's take a look at how the SSH connections are set up and what the packets themselves look like. So when you initiate an
I'm going to go ahead and just speed this up to 1.5 because I've got a good amount of videos to get through and I don't want to waste too much time on this, but I am still interested in wanting to make sure I really understand how SSH works.
SSH connection, you first are establishing a TCP connection between the two machines. Well, usually you can technically do SSH over something like WebSockets, but generally you're going to be using TCP. Now, for the packet itself, at the beginning of it is the packet length, which is 4 bytes in size, and it simply tells us how big the packet is going to be. Then you have another byte, which tells us how much padding the packet is going to have. Then you have the payload. So this is the actual data that you want. And then you have the actual padding. So this isn't the padding size. This is what we were referring to before. We were talking about how big the padding is. And it can vary. That's why we define the amount at the beginning. Now, to explain this padding simply, it's just random bytes that don't have any real meaning other than to be combined with the payload and then have the whole thing encrypted in order to make it harder for somebody who is sniffing this traffic to detect exactly what is going on. Like I mentioned earlier, the encryption just makes it so that you can't read the data plainly, but you can still try to infer things from the amount of data being transferred and how it's being transferred. So the padding makes this a bit more difficult to do. I guess it's sort of like if your neighbor had decoy packages on their porch mixed in with the real ones. And then you have at the end a message authentication code, which is sometimes called a tag, which is used to validate the authenticity of the package. Basically, it tells the recipient that none of the data in the packet had been tampered with along the way. And also, some kind of compression is oftentimes applied to the payload so that you can send more data without having to use more bandwidth, because chances are that's going to be the bottleneck here in the connection is the bandwidth.
Mint Mobile Unlimited Premium Wireless 30/30
With the price of just about everything going up during inflation.
So Well, this is the plain text structure, but then when the packet is encrypted, all that anybody that is in the middle listening communication can read is the packet length and then the message authentication code. Now, the particular encryption that is used for all of this is negotiated between the client and the server. Of course, either the client or the server could configure their preferences to disable the use of weaker encryption algorithms, and that's actually an ongoing recommendation as different encryption methods become obsolete over time. And this process is then repeated for multiple packets in a continuous way so that your communications are, well, your communications, of course, are always going to be made up of many, many packets. So this is that they're all going in the right order and nothing's getting messed up. Now, on top of this, you also have a series of channels that are being opened between your machine and the server. And what this enables you to do is to have multiple connection between you and the server at once. Like if your terminal has tabs, or if you open up multiple terminals, if it doesn't have tabs for whatever reason, and you might have multiple connections to the same server. So maybe you have one that's uploading some data, another one downloading, and another one that you're actually really just using the shell and like some kind of terminal-based text editor to change configurations, and then maybe you're saving and then restarting some services, whatnot. And you could also have a fourth connection going, acting as like an SSH tunnel. So taking something that would normally be encrypted or normally not encrypted and then tunneling it through SSH. So all of this is made possible, and it can be done at once with the multiplexing. So SSH actually has a lot to it that you might not have previously thought about or known about. And another cool thing that you could do with it, particularly in a Linux environment, is you can have X11, which is basically the core windowing system for Linux operating systems. Well, there's Wayland now too, which maybe you can do over SSH, but X is still more widely used. Anyway, it's possible to forward X11 over SSH, which means that allows you to run graphical applications on a remote machine over that SSH connection. So pretty cool, right? And then, of course, there's the tunneling that I mentioned earlier, which can let you do things over an encrypted tunnel through SSH. Or if you wanted to connect to a service behind a firewall, you might also accomplish that with SSH tunneling. So that wraps up this summary for how SSH works. If you found this video useful, be sure to leave a like, comment, and share the video with your friends, as well as subscribe to my Odyssey channel for more great videos. And you have a great rest of your day.
That was a pretty good video.
We did a video from a while back on the SCP.
Trying to think. I guess I don't really need to save that. I can just find it again. Actually, I will share that link, and I'm just going to pull it over to. Basically, I'm wanting to pull it over to my personal tabs, because what I would like to do is add it to. Actually, I don't know why I'm pulling it away. You guys can totally see. Oh. You guys can't see. There we go. So what I would like to do is add it to my Reader application. This is something that it's a program that you can just add anything to, whether it's a video, an article, whatever. And if and then you can take notes on it, and those notes get synced to Readwise. So this is the Readwise Reader, and it gets all the notes get synced to Readwise, the actual application, and then those can then be continuously exported to multiple different note-taking apps. I use Notion, and so that way, as I'm reading something, I can be taking notes on it or highlight. Maybe I don't want to take a note, but I just want to highlight something, and then that automatically gets synced to my Notion. And if I think of, what was that thing that I read, then I can just search in my Notion, and boom, there it is. So super helpful. When it's something like this, like it's just a video that I thought was good and that I liked, but I don't have anything that I necessarily want to save on it, I will still save it to my Readwise, and I'll just archive it. And that just means that if I'm talking to someone else, let's say at work, and we're talking about SSH, and they're like, I have a question, then I can go, I watched a video about this recently. Let me go find that. And then I can just go search up in my Readwise and find it super easily. I've done this in the past with different coding related topics, and it's been incredibly helpful to be able to remember, I watched a video on this, or I read an article about this and it was really good. Let me go find that again. And just be able to boom, there you go. So I do it in Readwise Reader, but you could totally do this in just creating a bookmarks tab called resources or something, and just save all the articles or videos that you watch that you think are good. if I was going to be doing that, I'd probably use Raindrop. I do still use Raindrop to manage my bookmarks to sites that I think are cool and that I want to be able to reference and remember, instead of putting them in my list of tabs in my browser. I'd rather just have them in a separate application. It makes more sense in my mind. Kind of one spot for everything. Okay. Back to this. And probably most of these I'll add to my Readwise reader. Let me unshare the window and just share the tab. We might end this coding session at the end of this video, or perhaps this SSH for GitHub, just because it's about hitting an hour, and I usually try and keep these to about an hour. So I've got other things that I would like to get to this morning that I didn't get to yesterday. So yeah, maybe we'll do another like half an hour coding session later on today. We'll see.
Exploiting the secure copy. And I thought it would be just a sort of interesting. We did a video a while back on the SCP exploiting the secure copy. And I thought it would be just sort of interesting to have a look in a bit more detail at how SSH works. SSH stands for Secure Shell, and it first appeared in the mid-90s as a sort of replacement for way of connecting to a remote machine over the internet. Up until that time, the technologies you had to connect to a remote machine, Telnet, RLogin, RSH, and so on, worked fine, but they transmitted all the data in the clear over the network. So if you logged into a remote machine, anyone with a packet sniffer between you and the remote machine could see everything you were doing on there. When these protocols first appeared, that wasn't a problem because the machines were probably only networked within the computer department of a university or a company. So the people who had access to do that were people who worked there, and probably the system administrators who had access to these things anyway. But as the machines got networked to other networks and you started to build the internet, if you had access to the network, any network that the data was traveling over, you could sniff the packets and see any of the data was being transmitted, including passwords and things. And so in 1995, Tatu Uoinen in Finland, I apologize if I pronounced that wrongly, was concerned about this. So he developed a protocol, SSH, Secure Shell, to sort of encrypt the data so that you couldn't sort of see.
Your father knows about saving money. Everything I'm wearing, I've had since boot camp.
What was being sent over the wire. You could see the data was being transmitted across. You could see how much data. You could see the frequency of it to a certain extent, but you couldn't see what the data was. So you could do certain types of analysis to see what's happening, but you couldn't see the actual data. And so SSH was developed as a way of encrypting the connection between two machines. But it actually does a lot more than that, because when you SSH to another machine, the first thing that happens is that you open up a TCP connection between those two machines, like any standard things. Although it doesn't have to be a TCP connection, you can actually specify that SSH uses any sort of reliable network connection to make that. So you could theoretically run it over an RS-232 connection. You could run it over the top of WebSockets and things like that. I know people who have done that sort of thing. So you've got a reliable transport between the two machines. And so SSH is sending data over there. And what SSH does is it breaks the data down into a series of packets. And just like any packet transfer, these things have a few fields at the beginning. So at the top, you have something that tells you how big the packet is. So you have the packet length. There are 4 bytes saying the packet is this big. After that, you have another byte, which tells you how much padding you've got. So you've got the packet length, you've got how much padding there is, and then you've got the data you want, the payload. Then you have the padding that follows that. And so what you do with each packet, after the payload, the data you want to send as part of the connection, you add a small amount of padding, just random bytes. They don't mean anything, but they sort of force the encryption to sort of make it harder to detect what's going on because you've got random data in there. See some of Mike's videos for more details on why you want to do that. And then you have some sort of message authentication code there, so you know that the data here hasn't been monkeyed around with, but it's actually what was sent. You can then apply compression if you want to the payload. So you can compress the payload using standard compression algorithms such as zlib or something to compress the data. And then the whole of that packet, excluding the length, is then encrypted. The algorithms used for the encryption and for the message authentication code are selected by the server and the client. They establish at the beginning which ones they offer, which ones they want to use and things. So that they're established by the client and the server. So they vary for connection to connection. And you can offer many, and you choose the one that's perhaps best for that connection. We'll ignore that for the purposes of this video. So we leave the packet length unencrypted because obviously we need to know how much data is coming. We encrypt the padding length, we encrypt the payload, we encrypt the padding, and we send the packet out over there. At the other end, that's decrypted by the server, and it then knows it's got the packet of data, and it can piece it back together. And then the same thing is done for this packet and every packet, and the encryption is done so it's continuous. You start encrypting this one with vectors from this one and so on, so it's encrypted one after the other. At the server or the client which receives this, you just reverse that process, so you decrypt the packets, you decompress the payload, and you keep the data and sort of stitch it back together. So you start off, you've got your TCP connection, and that's unencrypted. And on top of that, you've got these packets which have been encrypted by the SSH protocol flowing on top of that. But that's not the end of the story. That's just encrypting the packets. That's not the connection that, say, if you SSH, that's not your connection to the remote machine. On top of that, you then open a series of channels that you send the data over. And the reason for that is it enables you to multiplex multiple connections over that thing. So when I start a connection to my machine, it's creating a channel on top of this. So if this is our one computer over here, and this is another one over here, we're creating this channel here for our shell connection where we can communicate and control things. But this is actually being represented by a connection through the SSH packets. And we can have multiple ones of these between the same machines, or we can have different types of connections. So for example, SSH also allows you to forward any sort of TCP connection over there. So you can connect to a remote service via the SSH tunnel. So you can tunnel that through and it's encrypted and then sent out at the other end. And if we make the connection with verbose mode on, we can actually see it setting up that connection. So what we've got here, it's reading the configuration data, its local protocol string is. So it connects to the remote machine. It sends back saying, I support this version of SSH. I've sent what my version is. We've then exchanged information about our compatibility, what mechanisms we use for encrypting the message.
I'm just reading it because I'm curious.
The packets over the network and so on. We've checked that we know the machine. And then we get down to here. We're now trying to authenticate. So it's now establishing, okay, this is this user on that machine. So I can put my password in. And we're now connected. But if we look here, authentication succeeded. We're authenticated to the remote machine. And you see here, it's creating a new channel. So it's creating a connection, which again, is just going to be, I send bytes down here. They appear at the other end. We send bytes the other way. They come back to us over this channel. And it's then setting up what type of connection it is. It's setting environment variables and things. And this is done by sending packets of data wrapped up inside the SSH packet, which establish that. Once that's done, we can then communicate and have our interactive session. So SSH is not just a sort of way of connecting a shell. It's actually got layers of things on top of that, which enable you to do lots of interesting things. So you can have multiple connections made over this thing. You don't just have to have one. And there's ways that you can set SSH up. So actually, you make the connection and it stays connected when you finish. So if you then make another connection to the same server, it reuses that existing connection and multiplexes the two connections in between things. It can start and stop forwarded TCP connections to other addresses in both directions while the connection's running, just by sending different things over this connection. The reason why it's got all this functionality is that often, particularly in the Unix environment or the Linux environment, when you're connecting to other machines, you may just want a remote shell connection, where you want to type commands and do things, that's right. But also the way the Unix X Windows graphical user interface works is that has normally done over a connection, usually TCP IP to port 6000, although it can be done over other things as well. And so that could then be forwarded as another connection so that you could log in to another machine and send the graphics commands back encrypted as well. Occasionally you may want to connect to a service behind a firewall, and you can do that by tunneling it through the SSH connection. So there's lots of reasons why it was built this way. But it's a nice feature. And I know I've been using this now for 20-odd years, 24 years probably now. But actually, you're still discovering new things you can do with it. For example, the fact you can keep a connection alive beyond when you've disconnected from the shell, so they can reuse that TCP connection, the lower level bits, when you create a new connection on top.
The more people you add to this group, so maybe you're a member of some kind of school thing.
All right, we'll do one more.
If you see your stake, you can register online to vote right now. It only takes 2 minutes.
Good afternoon, friends.
This is about the setting up SSH for the GitHub repository. So hopefully this will kind of make a little more sense of, okay, we figured out what SSH is, how it works, and all of that. And then now we're going to bring a full circle to how is it actually useful for what we were using it for, i.e. the GitHub repo.
This is Sergey Kromchenko, and today we're going to discuss SSH. A lot of you have been adding to repositories as contributors. A lot of you have been creating your own repositories in the GitHub, GitLab, Bitbucket, or any other repos, and you want to connect to it through the SSH, especially with GitHub, because they have recently dropped support of the HTTPS or username/password, as you know about it. So how do we do that, and why do we need it? Well, whenever you want to pull repository, or whenever you want to push your code to some repository, you need to be authenticated to it. Pretty much, you need to be logged in somehow to let GitHub or GitLab or Bitbucket know that you are exactly that user that has access to the private repository. So how do you do that? SSH is the way to do it. SSH key pretty much allows you to be authenticated to the remote repository so you could push and pull code to it. But before we get straight into it, don't forget to give me that big fat thumb up, subscribe to our channel below, and join our Instagram and Telegram communities that you can find links in the description below. Situation number 1, someone have added you to your GitHub repository and you want to clone it. As always, you navigate here, you click on SSH, click here to copy the URL, then you navigate to your Visual Studio Code, type in git clone, Command V to paste it, and hit enter. And what do you see? Permission denied, public key. Please make sure you have the correct access rights. Exactly, you do not have SSH set up. So let's follow up an instruction. Step number 1, let's Google GitHub generate SSH key right there. And click on the first link. When you click on the first link, you'll open up a docs.github.com URL on the page, and then you will see the following instruction. So open your terminal and paste the following command. And when you copy this command and paste it into your terminal, please make sure to update URL to the URL. I'm sorry. Please make sure to update your email address to the email address that you have used at your GitHub account, at your github.com account, which in my case was, let me see, profile emails. My email was codemify@yahoo.com. So I'm going to go ahead, come back to the VS Code, paste my email address, and then hit enter. So what this is going to do is going to generate a public and a private key. By the way, it asks you to enter enter the file name, which to save the key. Just hit enter. That's the default option, and that should be way enough. The second question would be enter your phrase. So they're asking you to enter the passphrase. I'm going to hit enter because there is no passphrase needed. I'm going to hit enter again, and finally, this is done. We have created an SSH key for the email above. Okay, I'm going to switch back to an instruction and see what is the next step. So step 2 generated, and then we scroll down, adding your SSH key to your SSH agent. We do not really need that. What we need is to click on add a new SSH key on the left side, scroll down just a little bit, and copy this command. Whenever you copy this command, please make sure not to copy $, because it simply means we need to run it in the terminal. So I'm going to switch back to VS Code, paste the command, and hit enter. After you run this command, your public key should have been copied into your clipboard, which means if you will run Command V anywhere, you will paste your public key. But let's come back to the browser and follow our instruction. So step number 2, we need to navigate to the browser, click on the GitHub icon, and then click on settings. Let's go ahead and do that. Click here, click settings. Okay, next step. And then we need to, in access section of the sidebar, click on SSH, and then click new SSH key. So there should be, we're going to scroll down. Let's see. They have mentioned access section, access, okay, SSH and GPG keys. Perfect. Click here. I'm going to remove an old one. You do not have it. This is just a testing one. So you will see a screen that looks like this. And you will need to click on new SSH key. Then call it whatever you want. I'm going to call it local key. And then I'm going to paste it right here. You can see my SSH key. I'm going to remove it after this call, so that's why I can show it to you, so you will not be able to use it in the future. Okay, after you have pasted your code, click on Add SSH Key. Awesome. Now you can see that your key was added. And now we can come back to VS Code and run our git clone command again, which is right here. I'm going to clear it first, and then I'm going to run git clone. And now, as you can see, we have successfully cloned the project Sergi. So now I'm going to run ls, and you will see Sergi. So I can open it and do whatever I want with it. This means that your local account now has an SSH key, which is connected to your GitHub account. So at this point, any of the repositories you have access to, like I can see on the left side, you will be able to work with through your local. You can clone them, you can make changes, and you can push changes if needed. Now, let me talk a little bit more about SSH in depth. So where do your keys get stored, and what do you do if something is messed up? Well, at the beginning, we were at web projects folder. So I'm going to run ls. And you can see that we did clone Sergi, right? But what if I run ls -la? So this command will show you also hidden files. In this folder, we do not have any hidden files, but we do have hidden SSH file in the root directory. And in order to find it, let's type in cd and hit enter. Now we're in the root directory. So now let's type in ls space -la. And when we hit this and we scroll up, you will see that there is a .sh folder. Let's go ahead and open it. cd.sh. Now let's run ls. And you can see your public key right here. That's the one that you have connected through with your GitHub remote GitHub account on GitHub.com. So if you ever have an issue and you want to remove it, what you could do simply, if you want to start completely from scratch, you navigate to your root directory, run ls -la to make sure that you do have that .sh folder. And then let's scroll down and type in rm -rf.sh. And what this did, it just removed that SSH folder. So now, if I run ls -la, you see no more .sh folder right here. And what does it mean? This means that if we navigate back to our folder, if we remove Sergi folder, and then we try to clone it again by running the same command, git clone, and then we paste it, and then we say yes, you're going to see that we're getting same error, that there is no public key, you have no access rights. And then what we could do, we could go back exactly to the same place where we came from, and we could start from scratch. Also, don't forget to remove your old SSH key since it was already removed from your local. Now we can navigate back and start all the way from the beginning. Now you know how to deal with the SSH and what is SSH used for. And finally, you know how to install or remove SSH keys from your computer. It is as easy as that. Thank you for your time, guys. Don't forget to give me that big fat thumb up, subscribe to our channel below, and join our communities on Instagram and Telegram, links to which you can find in the...
I'm curious what I have on my work laptop because I don't remember setting up SSH in that way. I'm trying to think what I did on that. I'm pretty sure. Oh, it was just a script. A script just ran. That's what it was. And so I'm curious to see what is in my git config file, the SSH config file, and how that all works. We don't use GitHub work. We use Azure DevOps. So a little bit different, but yeah, it's gonna be the same types of security. That's all gonna be the same. So let's see here. Obviously, you won't be able to see my screen, but I'll get through this and talk you guys through what I'm looking at. So, excuse me. I use Windows at work, but I'm going to navigate to the home directory, which is pretty easy. It's one of the saved areas, and home is just going to be my user. Let's see here. When I say user, like you're going to go to your local disk, which would be your C drive on Windows, or on Mac would be your actual like hard drive, and then go to users, same thing on Windows, and then your actual user account there. So I'm going to go there, and I'm not sure if I'm showing hidden folders, so I'm going to click. Excuse me. I'm going to actually forget how to show hidden folders. Options. Show hidden folders, files, and drives. Okay, sweet. That's click this show. So I think we're good. So I'll just hit OK. And then go to my user. And I see a .ssh folder. And inside the folder is a file. It says node_hosts. I'll go ahead and open that in Notepad and see what it has. Looks like it's got a date, or no, not a date, an IP address with the port, and then a public key. So that's interesting. And then let's see here, back in my user folder, I don't see a GitHub or a git config. Oh, there it is. I lied. Let's open that in Notepad as well. We've got a credential that says helper equals manager. I'm not sure what that means. And then user, which is my name and my email. So I bet that credential helper equals manager eventually somehow points to SSH. Interesting. All right. I think that's it for today. Computers are absolutely fascinating. There's so many different things that I just don't know. They're just so like the complexity. Anyway. All right, I'm gonna go ahead and end it there. I know we didn't get to what I said we'd get to was actually writing some code, so that's a little frustrating. But we are just share my full window. We are able to push those commits up and see them in GitHub. So that's super good. And yeah, I guess next stream, next time I see you guys, we'll actually put some code on the screen and install Material UI and then put some code on the screen and get something showing. So that'll be cool. All right. See you guys.